So we have this matrix, which is 3 by 3. It's all zeros, and we want to put 1 in this position, but not just in the last row. We want to know which is the first empty row. So we can ask, okay, in which position there is already a piece? We could use index for that. So if we do matrix 0, which is the column, so I now have this vector here, 0, 0, 1, yes? And now I ask, okay, index is like asking, okay, in which position is there a 1? Okay, I can print this. It will say a 2, yes, because it's in position 0, 1, 2. So now I know that I cannot put a 1 in this position because there's already 1. So if I wanted to change it, let me do something like this. In position 2 there's a 1. Now, and in position, wait a sec, in position 1 there's a 1 as well. So I want to print the matrix, print matrix, matrix. Now I placed 2 pieces in the first column, 1 and 1, yes? So they are both from the same player. Now, when I ask, okay, where is the first 1 in this column? It says, okay, in position 1, which is this one, 0, 1. So now I know that I can only place a 1 in this position here. This is very useful for you. For instance, you could check where is 1 or 2, so you could pick the minimum, because you know that if there's a value in row number 2, there will be a value in row number 3, 4, 5, etc. So using this function, you can know which is the first occupied position in your board. Yes? This will be really useful to know where to place the next piece. The thing is, remember, you don't have only player 1, you can have player 1 and player 2. So if you have it this way, it will say, okay, the first position is, or say the first occupied position is position number 2, but that's not true because position 1 is also occupied. So we'd have to do something like mean between matrix index 1 and matrix index 2. So I want to know which is the first position being occupied, and I just placed my piece over it. So in the next position, which is the first available position. Yes, so this will give me first available position is equal to this, and now I can put my piece. If the user picks the column 0, what row will we place our piece on? You know that? If I do this like this, first pause, do you know what will happen? So if I do it like this, we print the matrix, so it's like this, and now I say, okay, in the position in first column, because we are modifying the first column, in position, first available position, we place a 3. Now, wait, I didn't print the matrix after the changes. Now, look, we are overwriting the piece of the second player. So we don't want the first ABA position, but the first ABA position minus 1. This is problematic because if we had one more, so this works. I can prove it to you like this. It places the 3 in here. If I remove one of the pieces, so for instance, I remove the second piece, now the 3 will be placed. Wait a sec. I already told you that you have issues. Okay. This is one of the problems you might have. If one of the numbers that you are looking for is not in the list, issues happen. So try to remember this. You need a try except whenever you're using index. Just for the sake of this explanation, let me add one more row, so you know, so you see. So, and now I'm adding a number in this position. I'm adding a 3 in this position. If I remove the 2, or if I add another 2 in this position, it will add the 3 one more piece above. the last, yes, I just subtracted one, but yes, first occupied position. Yes, and now you can do this like this. The same thing, yeah? Problem, yeah, exactly, good one. What? After the row 0 is completed? Because there is no 2 or 1 in the 0 row. Yes, exactly. That's a problem you might run into. So you have to think how to compute this without the program crashes. So you will need to compute this with a try except because this might fail. You need to compute this with a try except because this might fail. And then you have to compute the minimum of them if they are both present, or just use the one that is present in that column. Yes? You not necessarily find both players in the same column. So you have to think about all the possibilities. This will be really useful to think, to find which is the first occupied position, or as someone was saying, the first available position. Problems. Imagine this is all occupied. Let's add one more piece in 0. Now, if I do this, so we have 1, 2, 1, for instance, let's say we have 1, 2, another 1, and another 2, yes? If I look for the first occupied position, yes, this will give me value 0, because the first occupied position is the position 0, so the row, the first row in the column, yes? The problem is, if I subtract 1 to this value, it will give me -1, and you know that the position -1 in a list is the last one. So the 3 will be placed at the end of the row, and it's something that we don't want to. So remember that 1, you need try excepts to make sure this index is present, so this number is present in your list, and 2, you need a if or a while or something. You have to think about it to make sure that you're not looking at the last position in the matrix. Yes, so if the column is full already, so if first occupied position is 0, print the column is full. If not, else place the thing. Yes, like this we avoid this problem. So right now they are the 4 rows are occupied in this column, so it says okay, the column is full and it doesn't do anything. Maybe we should use a while to ask the user again for another column, etc, etc. If we remove one of these pieces, then the column is not full and we can place a 3 here. Yes.